Leading, what's the y-intercept again, Kayla? And then which one of these is this? So I'm going to go back down to letter B. And actually, it's the y-intercept that makes it stick out. So which one is it? The second one. So this is letter A. And then this should help everyone else that's going. These are in standard form. This is not what I had yesterday. I think yesterday we had it in factored form when we talked about, that situation. In standard form, the y-intercept sticks out like a sore thumb. How do you find a y-intercept? You plug in 0 for what, everybody? X. So when I plug in 0 for X, everything's gone except -8. So that's why that is letter A. All right, next, Matt. Oh, let's do this. This is why I have two calculators going. Boom. But Matt, you want to pick someone or randomizer? Randomizer. See, I want to see if someone's ruthless. Say, I'm going to pick that person. I love it. I almost hit the wrong thing. 4, you have to trust me. Student number 4, Ryan in the back. Nice. So, Ryan, what's this one? Leading coefficient, positive or negative? What's the y-intercept? And then what does that make this one? Last one is correct. So we'll call that letter B. So should be nice the rest of the way here. Gracie, let's see. Boy, can we get 3 5s in a row? I just think this adds an element. Ooh, 1. That means you get skipped. Ryan, you're up. Okay, 3. Oh, sorry, Ryan, you got to go again. Okay, so Ryan, it's easy though. What's the third one? Positive or negative? Negative leading coefficient. What's the y-intercept? And then why don't you just take care of the rest of them? Which one is this one? The first or the third one, I mean? Yeah, so this is, that's C. And then the fourth one, leading coefficients, what? Yeah, it's pretty easy at this point. Now, what's the y-intercept? 0, 0. And then that obviously is the first one, letter D. Okay, so not too bad. So we gotta jumble between the two different forms. Actually, after this, we're gonna go back into x-intercept form. But again, remind yourself, how do you find a y-intercept? What do you plug in? 0 for x. So it doesn't matter. Just when you're in that intercept form, it'll just be different in order to calculate it. So that's coming up later. Sorry, I just wanted to hide this. Then I'm going to jump to this and just see that you have this going on. All right. And hopefully you did finish this. If not, just count this as like doing notes the old fashioned way. Here are the notes, just do them. But we did want to get this done in class. So I hope you understand, seeing my picture here too, that a cubic ends like this, right? If it's a positive leading coefficient, see my arms? I'm going to do the polynomial dance this whole chapter. And then if it's a negative leading coefficient, it ends like this. Okay, got it? Right? And then that's what's happening there. But notice it's impossible to have 0 x-intercepts with a cubic because either it's going to get hit with this arm or this arm, or vice versa. At least one x-intercept will happen. Maximum 3. And that is actually, listen, this sounds so major. This is the fundamental theorem of algebra. The amount of factors equals the amount of zeros you have, which means that's the maximum amount of x-intercepts you could have. But you don't necessarily have exactly that many. You could have less. It could be 5 x-intercepts or less. Okay? It all depends on how those shake out and some things that we're going to talk about today. And then you ever hear of an imaginary number? You better say so because we had it this year. Remember imaginary numbers with a quadratic meant it doesn't cross the x-axis? So then we have that problem as well. They're zeros, but they're not x-intercepts because they're imaginary. So we got that coming up. That's definitely part of this chapter. Okay, and then notice the bouncing. Letter D, we're going to talk about that actually right away in the very next section here. Okay, I think if I got my timing of the notes correct. Are we good on this? Move on a little bit here. Well, that's what we were looking for here. I think this one says 3/2. And 1/3 is an estimate. If you put a half or whatever, some sort of decimal that's close, it's an estimate on those fractional or decimal zeros that are not exactly on an integer. Okay, so kind of just showed that. Now, I did want to do this too. Go to your graphing calculator real quick. I'll show you another feature. But yesterday's homework should have been no calculator. You should have tried to evaluate without it. How I filled in the numbers, and have a real nice chart, and then those dots done. And just make sure your quality of work is there. Otherwise, you will fall behind for sure. But what I want to do is, okay, I already did it. So for time purposes, I'm going to leave it. So go ahead and type in that function just to see, is that the picture that I get? Do I trust this in what's going on? And even when I teach this in CAT, this is just kind of shoved at them. This is what happens, and you just have to kind of accept it. And I'll tell you what that means in a minute. The type of zeros and how the graph behaves at those zeros. So I want you to go to y equals, type this in parentheses, be careful. Do not press graph yet, though. As a matter of fact, I will do something that I didn't do last hour. Question? It's a XT, it's right here. It's right where my pointer is, right next to alpha. Okay, so it's right there. What else? You got that all typed in? I'm not saying those that don't, if you don't have a graphing calculator, we'll see. I'll have to talk to the crew tomorrow, the Math 2 Honors teaching crew, if we're going to have graphing calculator type questions. We could do this whole unit and still be fine without having to do what we're doing here. I'm just doing this for an extrapolation and also just get used to using a graphing element of the graphing calculator. Now I'm going to hit what's called zoom standard. What zoom standard does, let's zoom here, is it puts my x and y axis to 10 and negative 10, both x and y. And then I just want you to understand what you see when this happens. Is that the picture that you see right here? Yes or no? No, it's like all weird. It's all distorted. That's because look at the window that they used here. They went an x-axis value from -4 to 3. And then the y-axis values, that's why the graph's cut off, because that only goes from 10 to -10. So this is the whole idea of manipulating your window so you see a good picture. So I'm going to go to window and do those manipulations. I'll make them equal though. So I'll go from -4 to 4. Common error is putting the x min 4 and the x max -4. Your graph will shut down. Your calculator will stop working. It will not graph when you have the windows minimums larger than the maximum. Don't worry about the other things. Going by 1 just means each tick mark on the y-axis and x-axis will go by 1. And it doesn't really distort too much. Now I'm going to go from -40 to 40 for y, because that's what this picture shows. Look at the y-axis values. It goes up to 30, but I'm just going to make it equal, 40 to -40. And then don't worry about all that other stuff. I haven't seen that stuff in a while. Trace step. I used to know. Look at a y-axis value. See how they're, see all those, we went by 1, so there's 40 tick marks on that y-axis. But doesn't that almost look exactly the same? Right? So I just wanted to show how the graphing calculator does verify that this picture is that equation. So that equation graphs to this picture. Now, here's a kicker. This is what you really have to understand. So put your calculator down for a second and watch me up here. What you have to understand is the first question is, what is the degree of this polynomial? And what you have to understand, my pen, of course, is they're asking, what if you actually multiplied this out? Yeah, my pen. Oh my gosh. So x minus 2 squared. Good factors are good whats? If I foiled that out, I don't want to blow your mind here, but if I foiled this out, this is what this would foil out to be. My pen is really being a jerk today. It would be x squared minus 4x plus 4. Now, I'm not asking you to do this in your homework. You're not multiplying these out yet. Okay, but what we have to understand is when they ask the degree, you have to think about if I did multiply this out, what would be the highest term? What would be the highest degree of this? If I multiplied out x to the x plus 1 to the third, that means I'd have to write x plus 1 3 times, which we did have you do that back in the day. That might have been August, September, October, somewhere beginning of the year when, things happened, I guess. But what this would end up being is x cubed plus a whole bunch of other stuff. I don't really care. Let's just pretend. We know that, right? You'd eventually have x times another x times another x. Do you get it? Yes, no? Now what happens if I multiply this times this and that answer times this? Really, all you have to worry about is, oh, eventually this is what you would have. You would eventually multiply an x times an x squared and then take that and multiply it by an x cubed and end up getting an x to the what? X to the what? Sixth. And you know what exactly the leading coefficient would be? 1, because each one of these have a 1 in front of them. So this ultimately would be a positive x to the sixth. And that's what you need to understand without actually having to multiply this out. So ultimately, this is what you do. Not all that, not even that you understood that. You would eventually have an x times an x squared times eventually an x cubed. And they all have 1 in front of them. So ultimately, this would end up being 1x to the sixth, ultimately. There'd be a whole bunch of other stuff lower in degree, but the leading degree dictates what kind of picture you're going to have here. Now it's time for me to do the polynomial dance. You ready? Okay, no, I don't know if you get to see me in this picture real well. My Star Wars shirt today, may the fourth be with you. X to the third, right? What's the leading coefficient, positive or negative? Positive. X to the third, right? Leading coefficient, negative. X squared. Let's go backwards. Parabola. What's the leading coefficient? Positive. So that's x squared, x cubed. And then when we keep going, this is an x to the sixth. How does it end more like? Does it end more like a cubic or does it end like a quadratic? Look at the ends. Well, it ends like a quadratic. So we're going to move up slowly. X to the fourth. Boom. And then what's the leading coefficient on this x to the fourth? Positive. Negative. X to the fifth. Leading coefficient. Positive. X to the sixth. That's how it works, okay? So even degree ends in the same direction. It depends upon the leading coefficient, what happens. You got to lock that in, all right? With our CAT students, we kind of, write it out, but it's really what's going on there. So it is a degree sixer, all right? Now, going to go ahead and list these zeros. So let's start with the first one, -3. Now, throw in a word here, the multiplicity of each. Oh, this pen. I'm actually going to stop writing. I'm not dealing with this anymore. Probably going to go to the key of the notes and just be done with it. But one thing we got to get out of this, remember this from parabolas. This is intercept form. X plus 3, -3 is a 0. That's because what's -3 plus 3, everybody? 0. What's 2 minus 2, everybody? So 2, comma 0. What's -1 plus 1? 0. So that's why the zeros are -3, +2, and -1, going in order what's happening with these. Now, what does multiplicity mean? Multiplicity means how many times it occurs. You never really write this with CAT students, but this is multiplicity 1. Because there is only one factor of -3 being a 0 there. Notice what happens with that graph. The behavior of that 0, it passes right through the x-axis. So that is the behavior, and that's what we're getting at. You can see something different happens with the other two zeros, which is going to be a lock it in moment. You got to lock it in your brain that this is going to be an always. All right, behavior of that 0. Also the type of the function at that. You know what you say when it's to the first power? That's a linear term because that's just x plus 3 raised to the first power, which is a linear situation. And if you just look at this one position right here, if you just look right here and nowhere else, doesn't that look straight? Doesn't that look like a line just in that one spot? That's the point. Okay, and that's the idea behind that. Now let's go to 2, just because I put them, I don't know why I put them in that order. I think I put them in the order that I had there. 2, multiplicity what, everybody? Oh, no. How many times does x minus 2 happen if I listed it out? Twice. No, x minus 2 times x minus 2 is two factors. So that's what it means to be multiplicity 2. There's your new concept. Lock that in. Really not a big deal. Notice what happens at that 0. What would the word be that I think that's been used on the previous page? It's a bouncer. And then what is the term for x squared? It starts with a Q. Quadratic. But really, what I want you to understand is, doesn't that look like a parabola right there? Right? Doesn't that one little position right here look like a parabola? All right. And the vertex is the x-intercept. All right. Another word for bounce, a better math word, I'm going to put it now. In the other class, I put it later, is the word tangent. And I think when I go back to just revealing the completed notes when we walk around the room, um, we'll have that happen. Where we at? We got the first row done, right? Good. And then the -1. Okay, here we go. All right. Let's see if you can get this now. Oh boy, this is gonna be tough. Second quit. I don't know if this is gonna be worth it. Hannah, nice. You get to go. Hey, what's the multiplicity on -1? 3. How would you describe that 0? Doesn't bounce. Does it go straight through? I mean, how does it go through with a little what? Little curve. Actually, it passes through, and it passes through like a cubic. So what we would say is maybe flattens out, which is kind of like what you were saying there, but it flattens out like a cubic. Like if you just put x cubed as a, y equals x cubed looks like this right through 0, 0. It's got that little flattening out right there. And that's what I want you to understand. It goes through that 0 like a cubic function. And that's the point. Hey, now watch this. I'm going to do this different than the other hour. Let's go back to this graph, and let's go and put this not squared. Now, here's what's going to happen with this graph. The loops are going to get really obnoxious because what I'm doing is making this pretty large number here. But I'm going to change that 2 to a 4. So what's the multiplicity now? Multiplicity what? 4. Watch the graph. Watch what happens at this 0. The loops are probably going to get nuts. So I'd have to change my scale a little bit. See, there you go. You're off the thing. Still didn't change that 0, but it's the next one. What is that graph still doing? What is it still doing? It's still bouncing. Notice it got flatter, right? But it's still a bouncer. And then you want to get nuts? Let's get nuts. Let's go to that third power and make it a fifth. Takes me a while on this one. You can go a lot faster than me. Plus, it's delayed, so I stopped clicking and so fast. 5. Now the loops are going to get nuts because I've changed these multipliers, which makes this get a lot steeper. But notice what doesn't change, the zeros. The zeros, that one, now isn't that more flat? But what does it still do? It still crosses with a flattening. Okay, so the point of this is when you have an even multiplicity 0, what does the graph do? Bounce. When it's an odd multiplicity, it goes through linear multiplicity 1, flatten out anything higher than that 3, 5, or 7, and so on and so forth. All right, forever. Okay, and that's just based on that, what you need to understand with this. So I'm going to go to the cheat and key and show what you should have written here. And I did put off to the side that you've seen tangent before. Remember a line tangent to a circle? It skips off the circle at only one point, doesn't cross through it. So it's not tangent, the trig tangent. Tangent means crossing without going through, kind of like a bouncing, a skipping off. So for zeros with even multiplicities, the graph will hit the x-axis but bounce, not cross. For zeros with odd multiplicities, the graph will cross the x-axis. Actually, I had that in the wrong spot. Sorry, my other hour. This belongs with the first statement. Yeehaw. Tangent to the x-axis. Oh, I did miss that one little thing there. Oh, well. So bouncing off the x-axis can be said to be tangent to the x-axis. Good math word, right? And then the graph, compare and contrast -3 and -1. They both cross, but -1's flatter. And I do want to see that. I mean, that's what we're going to do next. We're going to have, I think we're going to make graphs. Oh, no, equations. Nice. Ooh, I can get some students in it. David, are you ready? Okay, David, I'll just tell you, I'm going to freeze this for people writing, and I'm going to pick your randomizer number. Okay, second quit. Okay, they'll know this on the video here. David, you got a 4. Do you trust me? There you go, Dave. It's a 4. Okay. All right, so you got that first one down at the bottom there. So we'll get to you in a minute here as people are still writing. Okay. Does anyone know what this says down here? Is that a certain language or no? Anyone recognize this language? Huh? What's that mean? So it does look I thought we have Japanese here. No one's taking Japanese. Do you recognize that? It's not just Star Wars? Is it Star Wars? Okay. Gotcha. Interesting. You know, Japanese, the reason this is they were when the movie came out, actually Japan came out with toys before Kenner came out with toys. And they were like not really they were like knockoffs. And those are actually worth a lot of money right now because they were the original ones and they were kind of rare and still rare. So I remember that being a story. I've heard that a few times, but okay, here we go. Ah, I'm gonna show the answer. I gotta flip this here. Okay, all right. So where did we go here? All right, so scatter. All righty then. Write a function for each cubic. Okay, so David, you did get picked. What is that one x-intercept there? What's the first one that you see from left to right? What's the x-intercept? Well, I just want to know what's the x-intercept first. What's that number? -2. What does that mean as a factor? There you go. And then is there any power on this? That's all I want to know. What would the power be on this factor? 2 or anyone? 2 or 4 or 6. I mean, kind of, you could say that, but we want to, and it probably isn't a 4 or 6 because otherwise that'd be a lot flatter and the loops would be a lot bigger. But I couldn't mark you wrong if you said 4 or 6, 8, 10, anything even. All right, that means it's a bouncer. All right, and then Genevieve. Oh, this is gonna be hard with the calc, but I just want to keep going with the game here. Nice, you get skipped. Congratulations, unless someone gets you back. Jad, sorry you don't get skipped. Okay, so Jad, what's the next one? So the x-intercept we can see is 1. What does that mean that is as a factor? So do I just write -1 in here? There you go. So we're writing a parabola. I'm sorry, not a parabola, a function that equals this. Now, Jad, here's one thing. I'm going to talk with you and then everyone else here. I make my CAT students sometimes put an arbitrary letter out in front of this because we could do that. I could actually type this in the graphing calculator. We'll get this picture. Then I could put like a 7 in front of this. You know what the 7 does? It just stretches the graph. It stretches the loops, but it doesn't change these x-intercepts. Or I could put a -1 in front of this. Ooh. Now, would that be right? Which one would be more correct, the 7 or the -1 that matches this picture? 7. Why? It has to be a what leading coefficient? Positive. So maybe what you might do is just put a positive there, just so you're noting that. I mean, you don't have to, but just noting that this is a positive leading coefficient. So this is what would end up happening with this. Okay, Cecilia, where's my mouse? Oh man, I got too many things here. Too many programs I'm trying to use. I'm getting confused. but I want to keep the game going. Nice. Do you want to be ruthless or do I just do the randomizer? Oh, darn it. I want someone to be ruthless once. Student number 13. Nice. All right, Adrian. Okay, let's do the full one all the way through. Oh, no. Okay, so first of all, first zero. So what do we get as a factor on this one? Starting with this one. Okay, 1, 2, 3, 4. Say that again. That's what I thought I heard. What's the next one? X plus 2, and then what's the last one? Okay, and then we'll go to the next one, which is, I got confused. That was Cecilia. No, Cecilia, you got skipped, right? Or you got a randomizer. Where's my mouse at? Oh, come on. Now my mouse stopped working. Everyone's against me here, technologically wise. Miranda, nice. Is that correct then for this picture? Yes or no? Is this it? Is this all I need? Yes or no? Meaning, is the end behavior good? Or do I have to put a negative in front of this? So I was just doing some dance there. Do I have to put a negative in front of this, or is the end behavior fine? It's good. Are there any other multiplicities? Or those just go straight through? So I don't have to add any squares or cubes on any of these parentheses. Yes or no? No. So we're actually all good on this. So gave you a tough question, but basically had to do nothing because there is nothing more to do with that one. Right? Everyone got it? Okay, you don't have to put really a plus there. It will be positive if you multiply that out. Okay, Evan. All right, let's play the game. What time do we got here, by the way? Oh, Evan. 2, 3, 4, you go. What time do we get out of here? Oh, I get to eat lunch too. I'm hungry today. All right. Oh no, this is always a hard one. Okay, but last hour the student kind of messed it up, but you could just do like what you did in number 2 there. 1 is a 0, so x minus 1 is a factor. 0 is a 0. So what's your first factor, Evan? See, that's what's messed up. If we just put 0 there, 0 times anything is going to be nothing. 1 is a factor, x minus 1. I'm sorry, 1 is a 0, x minus 1 is a factor. 0 is a 0, so x, come on, Evan, minus 0. Okay, so that's what we got to get out of this. This is x minus 0 as a factor. I know it's silly to write that, but you definitely can't write 0. All right, 0 times anything is nothing, and you don't have a polynomial then. Students mess this one up all the time. By the way, what's x minus 0? What is x minus 0? It's just x. But the thing is, people never write it. They never write x when 0 is a factor or 0 is a 0. I know that sounds redundant, but it's not. Those are two different things that are being said there. All right, Evan, what's the other factor? So 1, 2, 3 is a 0. So what do I have? And then is there anything on that power-wise? What's the power on that? What's the multiplicity? It's a bouncer, so it's at least 2, 4, 6, 8. Who do we appreciate? Okay, and then now we go, if this might be the Adrian, it doesn't matter, man. You got randomized, and now it's your turn to, all right, so you got randomized. Randomized, or you got to pick someone. Let's be ruthless. Oh, man, everyone's so nice in this class. My cat students, they're like, Miranda, I got bad news. Number 10 came up. All right, so Miranda, you know what's funny? It's the same question. Maybe the calculator knew. So is this the final answer? F of x equals? Or do I have to do a little different thing here? You add a negative out in front, and that's the best way to do it. What I have my students say is A is negative. You know, they put an A in front of there as a multiplier and say A is negative. So you're actually good on that. Okay, I'm going to have you in the last, what do we have there? 10 minutes. You're going to go ahead and go to this page and do the best you can getting those pictures. And I can't pause this video, but I do want you guys to go ahead, and then I'm going to come out and see what you got there. So I'm going to end the video, and then I guess, yeah, I know what I'll do. You guys go ahead and do this. I'm going to freeze the screen. I'm going to finish the video by showing the video, the final answers for these. So you go ahead. So I'm going to talk to the computer for like a minute or two. Okay, you guys at home. The whole point of this one is you want to get this picture based off of the factors, turning them into x-intercepts, assessing if there's any multiplicities. They do ask you to do the limits too, right? Do you see that? Limits for end behavior and y-intercept. By the way, class, everyone here, look. How do you get y-intercepts again? What do you do? What did I tell you do? Plug in what? 0, 4, x. So what's 0 minus 5? So -5. What's 0 minus 2? -2. What's 0 plus 1? What's -5 times -2 times 1? 10. The y-intercept is 0, comma 10. You should not have to write that out. You plug in 0, and it actually does end up becoming something that's kind of easy to figure out. Okay, so you guys at home, if you wanted to pause the video and give this a try yourself, go for it. And then I'm going to reveal the answer here. Boom, boom, boom. Let me zoom in on this real quick. And then go here. There it is. Okay, so they do ask for limit notation. They do ask for the zeros and the y-intercept. And then there is a representation of a sketch. You guys in class, you're making a sketch. I couldn't care less how high and low some of the loops go, but do try to note the y-intercept as well. So try to get the x-intercepts. Don't try, do it. Look at my computer, right? Try not, do or do not. There is no try. Got that at the White Sox game. But x-intercepts with the y-intercept and expected end behavior, what the graph should look like. Okay, go on and proceed to number 2. Number 2 was the hardest for last hour when I walked around. But I'll go ahead, pause, and then show. Definitely have this. It's this end behavior. Because if I multiplied this out, this is what would occur. Don't actually multiply out, but think about it. When I FOIL that second set of parentheses, you actually do get this, but then ultimately you have to distribute that. So really, this is all you need to know. Right, I'm going fast for my class here. This one a little bit standard, but this one was tricky. Okay, that one actually ended up with this happening. Try to be cryptic so the other class doesn't hear me. They get their own answers. Then the last one, we just got a standard one of these, which makes this happen. So this is your job. Getting the y-intercept is nice, and then yeah, that actually is a good picture with that. I don't really care how high and low these go. That's what you don't have to really worry about. So that's what I was kind of like thinking about here. Just get the x and the y-intercepts, and then a reasonable picture about end behavior. Okay, so I'll shut down your video because I'm going to check these guys, what they're doing. In the other hour, I didn't get to these, but, I think the answers could vary on this. Yeah, 3 x-intercepts, so answers vary. 2 relative extrema, so, that's a relative max and a relative min. This one's a little bit more specific because it actually gives you what the x-intercepts are and actually tells you where a minimum should be. So you do have to actually graph that one. Leading coefficient, that's negative. So yeah, good stuff there. Okay. End your video.